Good morning, Mission Control. Well, sorry it's been so long since my last video posting. A few things happened. It was Valentine's Day last weekend, and I took Mrs. Martian out for a nice romantic getaway, and we had a great time. It was awesome. Unfortunately, as soon as I slowed down and took that break, my body said, hey, guess what? Now that things are going a little bit slower, we're going to go ahead and catch up on being sick because you've worked us right into the ground. So this last week, I think I either caught the cold or flu or whatever, and basically I was just super tired, runny nose, started to get a little fever. So besides working my day job, I just came home and went straight to bed and got some sleep. So starting to feel better there, on the mend. Thanks everybody for your prayers and wishes. Really appreciated that. And today I wanted to give you an update on what I've been working on, and sadly I don't think I'm going to be able to post a video every day like I was for this particular project because it's taken me quite a while to learn how to do everything. So the project is right here in my lap. Here we go. This is it. All these wires. For all you guys out there on traditional homesteads, this is probably the point where you might start phasing out on me, but give me just a few minutes here. I want to explain why this is important. And I'm not going to go into too much technical detail this time. I just want to give you an overview. So what we got here is a sensor suite. And my goodness, there are a lot of wires, aren't there? Kind of easier maybe to look at it this way. And this is going to be a sensor suite that goes on lane 2. Lane 2 environmental sensor suite is what this is all here for. And what we have is a temperature and humidity probe for the air. We have a dissolved oxygen probe. Vernier Optical is where I bought these from. So this will detect how much oxygen is in the fish tanks, so we can keep the fish nice and healthy. We have a pH probe. It'll also go down into the fish tanks. This little cap right here is just a solution to keep the tip wet and to calibrate it. But the probe itself just will be hanging down into the water. And then we also have, let's see here, a PAR sensor, photosynthetic absorbable radiation. What this means is out of all the light that we see every day, plants don't need all of that sunlight. They actually only need a few frequencies out of that. I think it's red, blue, and soft white are the three key frequencies that it needs, and this particular device right here will measure how much PAR, P-A-R, is coming into the grow beds, and that'll allow us to figure out if we have enough light for the plants to grow healthily. And then the last two sensors are exactly the same. You've seen these before here on TheRealMartian, and this is just a temperature sensor probe right there. So why is this important, and why did I ask you to stick around? So automation can be good and it can be bad, and putting together experience is the bad piece of it, but the good. This last weekend when I went away with Mrs. Martian, we were able to go away and know that the system is being monitored and that it's mostly automatic now. With the heating system we've put in, it's on timers, everything runs, and we were able to get away for one day. Had I gone any longer than a day, though, I would start worrying. I'd start wondering, how are the fish doing? What's the temperature there? What are the nitrates and the nitrites? And those two sensors I don't have yet. They'll be coming, and I'm going to install them after I install this. But I have it all wired for it. Anyway, the point of the story is that if you want to have a system like this, and if you want to be able to go out and still do things, whether go to the movies or go to the beach or go to the mountains and ride horses for a few days. That's what I want to do. You really can't leave unless you have a way to monitor and actually control the system. And that's what this automation and what all these sensors are really going to help out with. I'll be able to see what's the temperature inside of the grow lane and turn heaters on automatically with this particular sensor. I will be able to know if we need to turn aerators on with this particular sensor for the fish. I'll be able to know if anything died in the lane or fell into the lane that is changing the pH. I'll know if it's getting too dark in the lanes and we need to augment with more lights. I'll know all these things with this particular sensor suite. So that's what I've been working on. Now, I kind of wanted to show you the process of here and what this big jumble of wires is. So when I start, I'm kind of relearning a whole bunch of stuff. So let me show you these things. So there's a lesson to all the kids going to college out there to be future engineers, or if you're thinking about it. First, keep your textbooks. Very important. Second, if you are an aerospace engineer and you want to focus on building airplanes and going to space like I did, and rocket ships and satellites and all that, pay attention to electrical engineering. I passed. I got A's and B's in this class. Or you have to take 2 classes. At least that's what you had to do when I went through school. Electrical Engineering 1 and Electrical Engineering 2. And I told the teachers, and I got commented on this. I told them, I'm the aerospace engineer. I'm going to be like the project manager, overseeing everything. I'll have an electrical engineer on the team. Big mistake, Indy. Big mistake. This class, if you think about it, pretty much everything in today's world is electronic. And a project like an airplane or a spaceship, a spacecraft like a satellite, although someday it'd be nice to build an Enterprise, but majority of all the systems are electrical. I'd say almost like 5-6 of the systems are electrical, and that last 6 is mechanical. And that's where most of us think is in the mechanical space. But this class, pay attention in. I don't care if you like it or not. Pay attention in it. I didn't really like it. It's hard to think of electricity. It's imaginary in some cases. But pay attention. And then keep your books. And once you're done and you've forgotten your class, get this book. Because it's really good. I love the Dummy series, man. They are absolutely phenomenal. They are not really bad books at all. I actually really, really enjoy them. So Electronics for Dummies and Electrical Engineering. Between these 2 things, you can get some stuff done. Anyway, so I'm having to relearn a lot of that stuff that I just talked about. So instead of doing detailed electrical CAD design and actually designing out and all the circuits and all that stuff, I know I can buy a majority of the stuff right off the shelf just from Amazon. So what I do, I call this hacking right now, not even prototyping, is I write everything down on just good old-fashioned paper, and I figure out the pinouts right here. And a lot of this stuff is all available online. And then I just figure out how to attach it all to each other. And I start off with a vision that, I want to have a box like this, and I want to have this, there we go over the top of it, and mount it to wherever I want inside of lane 2. So then I start playing around. I'm like, okay, well, you're going to need, let's take this apart here. You're going to need a microcontroller. And I don't want to go out and buy heavy-duty industrial stuff right now because I don't really know what I'm doing. I'm trying to figure it out. I know what sensors I want. I know why I want the sensors. I know why they're important. But I don't really know how I want the whole thing to work. So I'm not going to go buy the industrial strength versions of all this stuff. So Arduinos are great. This is the Wemos D1R2. It is over-the-air programmable, so I can sit in the office or be someplace else on the planet, and I can send it updated programs. It's Wi-Fi, which is key because all the stuff in Hab 1 is all Wi-Fi controlled. So you need one of these to have a little brain that tells tells all this data collected from the sensors where to go. And then as I was building this thing out, I actually made it to the point where I got it all looking like this. And what we're using are little clip-in RJ11. That's like your telephone connector. We're using clip-in versions of these. And then you just run the wires to the back side of them here. Pretty easy. And then you can just clip in your sensors. You buy the tool that allows you to put this all together, and you can just clip that right in. Really nice, simple thing. What we got here is basically these 2 big things. This is my 5-volt bus, and this is my ground bus. And we got lots of wires. This particular wire has resistors inside of it. I actually had to figure out Ohm's law again and do a voltage divider. And then we have a 1-wire sensor. Some of you will know what that is. Others, don't worry about it. And this one actually has a resistor in it as well. So, you know, when you're building stuff in a wood shop, you kind of follow a similar process, right? You think of something in your head, you write it down on paper, and then maybe you mess around with a few pieces of wood first before you actually, you know, build a really nice version of it. And this is essentially that. This is a hack. I mean, look at it. It looks like a small alien or something like that. Yeah, kind of aggressive looking thing. I'd like to clean this up a lot. I won't even call this a prototype. It's just a hack to figure out all the wires and connectors that need to go together. So I got this put together. That took me quite a few days, stripping wires, making sure everything fit right. The right size wire is very important. About 22 to 24 AWG is what you need. Otherwise, you will get shorts, as I figured out. Another thing is on each of these boards, you know, I bought it and I'm like, oh, there's plenty of input-output signals on here. But sadly, there wasn't. So I had to buy what is called a multiplexer. A MUX for short, MUX. That's this little guy right here. What this does is you plug it in to your digital signals. Here we go, just like this. And it takes one pin and it turns it into 16 different pins. And these pins, each one of them can receive a signal now from a sensor. So we've taken this digital thing and we've made a whole bunch more analog signals. And analog signals just read voltage. A lot of these sensors, what they do is inside of here, there'll be some more electronics. And the sensor, when it's given a little bit of power, 5 volts, it will create a return voltage. And what you're doing is you're reading how many volts are coming back. And it's going into this signal here, and then it runs through the board into the analog input. So, yeah, I got all this put together. I got it all wired up. And when you're putting it together, just a recommendation, I tested each and every single one of these wires for signal integrity. Right here, you can get a little cable tester and make sure that everything's connected correctly. I did that, and that took a long time. And then I got it all put together. I got it all wired up to this bad boy. And the code is extremely easy on these because it's all analog. Very, very simple to write. So I put it all together and I started testing. And I found out, basically, I had a bunch of shorts in the connectors. Shorts meaning somewhere 2 wires came together that weren't supposed to. And what I found out, like I alluded to earlier, is that these RJ11 jacks, I had a little bit bigger, I think it was probably like a 20 AWG wire that I tried to shove in here, and it shorted out, and that caused a lot of problems. It took me a while to figure that out because I'm like, what is going on? But anyway, you want to use 24 AWG is RJ11 wire, and that's really what you want to use. So putting this all together really isn't that bad once you figure out the signals and everything, which are available from Vernier.com. Nice little company out of Oregon that makes sensors for schools and all that. So, yeah, the wires were shorted, so I fixed all that, and then I finally got all the sensors to work, and then I had one last sensor to add, this little guy right here. This is a carbon monoxide sensor. And what I wanted to have happen is, if this thing detected carbon monoxide, I wanted a little LED light to go off that's going to be mounted to this box, right like here or somewhere. And just to let people know, hey, carbon monoxide, do something. And that's because of the heaters that we use, of course. We have convection heaters, so they're burning stuff. Want to make sure we're safe out there. As soon as I hooked that all up, this whole thing stopped working. And I've taken it mostly apart and put it back together once already, and now I get to do it again because somewhere something went wrong as soon as I installed this. So again, part of the hackathon here is to get this whole thing to work correctly. So now I got to go and troubleshoot. Probably somewhere I have a wire touching another wire in this bundle of mess, and I just need to go find it. So anyway, I'm going to be working on hacking this thing together. So probably a few more days before my next video as I figure this all out. Hopefully next time you see me, I'll actually have everything put together and installed. But if things go wrong, I'll give you another update with the lessons learned. I'd like to do some more detail, like how to put this stuff all together, but honestly, I think you can get better videos from people who do this for a living on YouTube, and I might mislead you on some things. I'll be very humble in that, saying that I don't know everything here, and I'm actually learning as I go. So, but that said, I have to build another one of these, and I'll probably take some videos as I put that one together so you can kind of see some more details. But anyway, I think that's all I got for you today. It's nice to feel better again. I'm on the mend. Thanks everyone for your support. Again, really appreciate it. If you like this video, be sure to give it a thumbs up and hit subscribe. And if you hit that little bell to the left of the subscribe button, you'll get notified when I publish new videos. In the meantime, this is The Real Martian. Out.